After understanding the differences between amorphous and crystalline solid, let's go into the types of the different crystalline solids. So, types of crystalline solids. Crystalline solids are of four types: ionic solids, covalent solids, metallic solids, and the last category is of molecular solids. This classification is on the basis of types of constituting particles. On the basis of types of constituting particles. So, now let us take these four types of solids one by one. Let us first take ionic solids. We will classify these solids on the basis of constituting particles, then we will do their examples, then we will do their interparticle forces, then we will try to find out their melting points and boiling points, and then electrical and thermal conductivity. So, these will be the parameters on the basis of which we will try to classify these and study these four different types of the crystalline solids. Let us first start with the ionic solids. We always have a misconception that only the ionic solids are the ones which are existing in the crystalline states, but it's not right. Even the covalent, metallic, and the molecular solids also exist in the crystalline state. We will make it very clear after this. So, let us start with the ionic solids. In the ionic solids, the constituting particles are your ions. The examples can be your normal rock salt, NaCl, KBr, Mg2SO4, like all these examples. All these are ionic solids in which the constituting particles are your ions, cations, and anions. The interparticle forces in these are your strong electrostatic forces. So strong electrostatic forces are the interparticle forces, and the melting point and boiling point of these are high due to what? These strong interparticle or electrostatic forces. Now, electrical and thermal conductors, they are poor conductors of both in solid state, but they can conduct electricity in molten as well as in aqueous state by the process called electrolysis, because then their ions are free and they are able to conduct electricity. So, remember, though in the solid state they both are poor conductors of both of these electrical and thermal conductors because they do not have free charges, but the moment you take them in the molten or in the aqueous state, they can, yes, conduct electricity. So, these are your typical ionic solids. So, let us take now the next category of the covalent solids. Now, let us study the second type of crystalline solids called covalent solids. These are also called network solids because they form large network giant structures. Now, in these solids, the constituting particles are your atoms, which are example like you have diamond, you have graphite, silicon carbide, which is also called carborundum, All these are the examples of your covalent solids which exist in the crystalline state. The interparticle forces in these solids are strong covalent bonds. Covalent bonds which are formed by the overlapping of the atomic orbitals. Melting points and boiling points. Their melting points or boiling points are the highest among all types of crystalline solids. The reason is because their interparticle forces, the covalent bonds, are very, very strong. They form very big giant structures. So their melting points and boiling points are highest. Remember, but they are poor conductors of both heat and electricity because they don't have free charges, so they can't conduct electricity. Though we have exceptions like graphite, which is a good conductor of electricity, which can conduct electricity, though diamond also can conduct heat, but those are the exceptions. But in general, covalent solids are poor conductors of both heat and electricity. So these are your covalent solids. We normally doesn't think about this. They can be the crystalline solids. Yes, they are crystalline solids. Let us move to the third category, which is called metallic solids. Now, metallic solids includes all the metals which are present around us. In these metallic solids, the constituting particles are your metal kernels. I hope you all are knowing what are metal kernels. These are the metal atoms which are actually given a positive charge in this state by the electron C model theory, and they are in the sea of electrons. They are in the sea of electrons, and the examples are your all metals like your iron, gold, silver, copper. All these are belonging to this category. Their interparticle forces, since these metal kernels are surrounded by the electrons, the forces are electrostatic forces. And since the forces are very strong, their melting points and boiling points are obviously very high, and they are good conductors of both heat and electricity. The reason is because they have free charges, these free electrons, which are available for their thermal and electrical conduction. So these are your metallic solids, and always keep this thing in your mind that all metals actually have a crystalline structures. They are the categories of crystalline solids. Then the last category is of molecular solids. Yes, even the molecules in the solid state can form, they can have a crystalline arrangements. They can be crystalline solids. So now let us see the molecular solids. But what is important to note here is, when we start molecular solids, we need to understand molecular solids itself are of three types, and the three types of molecular solids are on the basis of the types of molecules which are present as the constituting particles. The three types of molecular solids are non-polar molecular solids, polar molecular solids, and hydrogen bonded molecular solids. So these are the three categories. We will take all these three categories one by one separately. Let us see the types of the molecular solids. Let us first start with non-polar molecular solids. In these, the constituting particles are your non-polar molecular species which don't have any polarity. The best examples are your noble gases, because they are the perfectly monatomic gaseous species. When they are solidified under high pressure, they form non-polar molecular solids. We can have CO2, CCl4, etc. All these will be the examples of non-polar molecular solids. Now in these, the interparticle forces will be your weak dispersion forces because they don't have any polarities, and therefore their melting points and boiling points will be very, very low, and that's why they are either are gases or they are volatile solids or liquids at room temperature. Like if we can take solid CO2, it will be a volatile solid. So these are the major characteristics of non-polar molecular solids, and all molecular solids are poor conductors of the heat and electricity, poor conductors of both because they don't have free charges. Now let us see the second type of molecular solid, polar molecular solids. The constituting particles in these are polar molecular species which have polarities, which have net dipole moments like HCl, NO2, SO2, etc. Now since they have polarities, they have what type of interparticle forces? The dipole-dipole interactions. So the interparticle forces in these are dipole-dipole interaction. But though they are not very strong interparticle forces, their melting points and boiling points are low, and that is why they are either gases or volatile liquids at room temperature. Now let us see the third type of the molecular solids called hydrogen bonded molecular solids. Let us take the third type of molecular solids called hydrogen bonded molecular solids. In these, we study those molecular species which develop hydrogen bonding between them. So the constituting particles are molecular species with hydrogen bonding. And the examples are water, solid ice, HF, hydrogen fluoride, and ammonia. They easily develop hydrogen bonding, they are having hydrogen bonding, and when the solid state, they develop extensive hydrogen bonding. So the interparticle forces are as usual hydrogen bonding, but the melting points, boiling points are not very high, they are low, but definitely they are having higher melting points and boiling point than the other two categories of molecular solids. They are what? They are liquids or volatile liquids or gases at room temperature. So these are your molecular solids. Out of these four categories, we try to study what? The metallic solids first, because it's much easier to understand metallic solids, all the properties of the solids, crystalline solids from the metallic solids, because the constituting particles are of the same size. And then we move to the ionic solids because there we will have particles of two different sizes. Cations will be smaller and the anions will be larger. So we mainly do two types of the crystalline solids in detail, the metallic and the molecular solids, ionic solids. But let us first do the understand what exactly are the different structures, how we study their structures of these crystalline solids.